So in the previous video, we looked at how to actually create this type of function where we pass in an array, it automatically adds to that array, and if there isn't enough space, it automatically reallocates it such that there is enough space. And what I wanted to take a look at today was exactly this reallocation. The amount of memory that we are reallocating every time there is not enough space right now is equal to double the old capacity, double the old size basically. But why is that? Why do we actually use double and not, for example, triple, or don't we just add maybe, I don't know, 10 more integers to the array? That's what I want to talk about today. So suppose this is our array, let's say, right? This 1, 2, 3, 4 elements is our array, and let's say that we have added all of them here, right? 11, 17, 18, 19, if I can write, and then 20. And we want to add another one. Then what we do in this current implementation is we basically double it, right? So we go like this, and this is going to be the same, of course. I'm not going to write the numbers again, but the size is going to double. So we have like 8 spaces here, but in fact we only have 1, 2, 3, 4, and 5 slots used. And those 3 are right now just, well, available for later use if we need to add more. Okay, so this is one way of doing it, and you can imagine that once we have more than 8, so let's say we have one more than this, we're going to double it again and have 16, and we're going to have again quite a few number of bytes free that are not actually used, but we are allocating them. So instead of doing this doubling, what if we just, simply make space for just one more element, right? Like that, and whenever there is one more element, I'm going to actually allocate more space for it. Well, we can try to implement it. It's actually very simple, right? Instead of multiplying it by 2, all we have to do is, well, I'm going to put it first into parentheses because I'm going to add to this capacity instead. I'm just going to say plus, and let's say plus 1. And same thing here. So I'm going to just add 1 to it. And if we try to launch this, let's say here like that, I'm going to do main. I should compile perfectly fine. You can see that the array basically has allocated 35 space for 35 integers, and we have 35 integers, right? And there's nothing wrong with this. Now, this looks fine, but what happens here is actually pretty bad for the program itself. It slows down a lot simply because we are telling our program to reallocate memory every time, and reallocating memory, or rather writing or moving memory from one place to another, is costly in computer science, right? And if we do this at every single addition, that would take quite a long time. So basically, all in all, whenever we have n elements to add to this array, right, we are doing n reallocations, right? N reallocations, which is not great. Okay, and whenever we were doing this reallocation where we were multiplying the capacity by 2, I'm going to change it here as well, right? Well, how many times were we reallocating in fact? And I can actually print here a message saying, I don't know, we reallocated. And let's do a backslash n here. Great. And it seems like I forgot a backslash n here as well. That's fine. And if I do here GCC and main, you will notice that we have only reallocated it 4 times, right? So if I change it back to +1, so I'll say here +1, and then do this and this, you can see that, yeah, basically n times we have reallocated minus 4 the initial capacity. Sure. And as you may have noticed, we have reallocated only 4 times, right? Because we only have to get to 64, and by doubling each time, so we had initially 4, we doubled it once to get to 8, we doubled it again to get to 16, we doubled it again to get to 32, that is 3 times, and then we had a few more elements, so we doubled it again to 64, we only had 4 doubles, right? So in our case, in the general sense, really we only get log, in this case log 2 of n reallocations. So in the first situation, we were doing about 31 reallocations, not considering the initial ones. And in the second case, we only did 4, right? And if we plug in here 35, we will be getting actually we'll be getting 6 in our case, but if we take into consideration the initial values, then we only get 4. This is a nice implementation that works very well, especially for medium to large sized arrays, right? If we have to add maybe 1,000 or 10,000 elements to the array, this would only do a couple reallocations and we'll be done with it. And you don't have to worry about reallocating ever again. But for smaller arrays, such as, let's say, an array of 10 elements that we want to work with, well, the first method, we are really just reallocating it 6 times. And for our own method of doubling every time, we're reallocating it, well, two times basically, because we start from 4, 8, and then 16, right? But we are wasting a little bit of memory, right? This number, this multiplication, you can actually tweak it a little bit. So you don't have to leave it at 2, you can leave it at 1.5 or 3 if you so desire. Depends how much space basically you think is okay to waste, right? But another thing to consider is the initial capacity that you can change, right? The initial capacity is actually quite important and would be useful to set it to a sensible, fairly large number, right? In my case, maybe I will set it to, let's say, 16, right? Because after 16, if you double it 2 times, it's already 64 integers, and after 3 times, it's already 100 or more integers. It's perfectly fine for my use case, but depends what exactly you are doing. If you are starting with, let's say, you know that at initialization you're going to add something like 1,000 elements, then start with that initial capacity, and only after that you will see reallocations. So in our case, if we launch this, let's try to do that, you will see that we only reallocate 2 times, because we're going from 16 to 32, and then from 32 to 64, and then only after another 29 elements, we're going to get another reallocation. So this doubling of the capacity is actually a very sensible default, and many standard libraries actually use it because it doesn't get in the way of large arrays, and with smaller arrays there always can be a sensible default that you can initialize to, or you can simply ignore that because reallocating 3 or 4 times doesn't hurt at all. I mean, when it comes to really large arrays, the reallocation can really cost a lot, and that's why multiplication of the capacity is very important, right? You can multiply it by 2, by 3, by whatever number you see fit. Just keep in mind that whenever you multiply, you are actually going to have some, wasted space, such that maybe you're not going to use this much, but later on maybe you will. So based on how much you multiply it with, right? If you multiply it by 2, you will always have a maximum of 50% minus 1 wasted space. If you multiply it by 3, you'll get a maximum of 66% minus 1 wasted space, right? But if you multiply it by 1.5, you're going to get less than 50%, which is probably where everybody will be okay with. Alright, that's about it for this video. I hope you got something out of it. If you do have any questions, leave them down comments below or on our Discord server. Again, the source code can be found in the description below. Take care. Bye.